Okay, so I have this house robber 4 problem. I think it was pretty fun to do. Um, I guess my first thought was that it was DP, but then I realized no, it's not DP. And then I was like, maybe you could do greedy. Maybe you could sort these nums and then choose which num um, to put in a subsequence, a non-consecutive subsequence. So then I was thinking maybe we could create a map, but honestly, I wasn't able to figure this out on my own. I had to read the 4 hints. Actually, honestly, more like 3 hints. The 3 was enough for me, and then I just looked at 4 afterwards to check whether my thinking was correct with the first 3 hints. By the time I read the 4th hint, yeah, that was not really necessary. So, yeah, basically, it's kind of cool use of binary search. Instead of like just searching um, for an element in the array, you're searching for like the result instead. I feel like there's another problem like Coco Eats Bananas that does a similar concept of binary search. Um, I guess the thing that I was struggling with after reading the first and second hint was I didn't really know what we were searching. So I guess this kind of reminded me that there are multiple ways to use binary search. The one that just searches for the element in the array, and the other one that where you could like search the answer space and not just an array. And then use a check function. And the check function, basically, if you read this problem through, you just need to make sure that it basically validates whether your guess from the binary search is valid. Um, in other words, it's like you can't have the robber rob adjacent elements, right? I think it's somewhere here. Refuses to steal them from adjacent homes. That was in bold. Don't know. I mean, I guess I highlighted it. And that was useful. But yeah, it was in bold. Um, so yeah, you could choose adjacent elements. Um, and the elements also have to be less than the guess because you're trying to find the minimum capability of the robber. And to find the minimum capability, it's like steal at least from at least K houses. And the things you realize with at least K houses is you could just you could just check the ones where the robber steals from K houses, because the ones where he steals from K houses are subsequences of the ones where he steals from more than K houses. So you just need to check the ones where he steals from K houses. I guess let's code this up again because I want to practice coding while talking so that I ace some interviews. Maybe. So for the binary search part, we have a left and a right. I like to do left and right. And then we're searching the min of nums and the max of nums. I mean, that's our search space. A search interval, I guess. And while L is less than or equal to, right? And note that we use this less than or equal to here. Honestly, I feel kind of confused about the less than or equal to, but from my understanding, we use this less than or equal to here because we do this check. We do a check to validate that the guess is correct. And if the guess is correct, then that means actually, I'll write this out, and then I think I'll provide an explanation later on, because then I could reference parts of the code so that you can understand it. So we'll have the middle value be equal to the left plus right, oops, L plus R divided by 2. And then we'll perform a check on this middle value, like I said earlier. So I'll just call this function check. We have this value, and then we have a count. The count just makes sure that we have a sequence with k houses, a non-contiguous subsequence with at least k houses, where the houses are not adjacent. Like, yeah, we need to make sure that we have that amount of houses captured by count. Okay, so then we'll have I equals 0, and then while I is less than the length of nums, what we'll do is we'll check whether the nums of I is less than or equal to the val, and we check. Okay, in this case we increment the count, and we do I plus equals 1, because we want to like not consider adjacent houses, and I'll have an I plus equals 1 right here. So then like if we find a house with a value that is less than or equal to this guess val, then we increment count. So like let's say we're considering 2, and then we increment I, so then we're at 3. But we don't want to consider 3 because we can't consider adjacent houses. So then we do another I plus equals 1 at the end of the while loop. And the next thing we're considering in the next iteration, the thing we're considering in the next iteration is going to be 5, which I highlighted. Okay. And then if the count, oh, I think I should do this in the front. So if the count, or no, at the end. So if the count is equal to k, you do greater than or equal to, doesn't matter, then we return true. And then if we iterate through everything and that doesn't happen, then we return false. The reason why we have this if statement after this if statement, after the first if statement, is because during one iteration, maybe like you're at that last iteration, and then perhaps 9 fits into, let's just say, let's just say there's some non-contiguous subsequence where we consider the last element and we add it into the count. Well, the next iteration after I is equal to the length of num, so then we don't return true. We never get to the return true if this return true thing was before this if statement. Okay, yeah. So that's why we do it after, so that like this count thing is considered at the last element of the array. Okay. So then we have if check of m. So if, basically where it's saying if there is a non-contiguous subsequence where there are houses with values that are less than m, and those houses are non-adjacent. So if that's the case, then we set the right value to m minus 1, because we want to consider like smaller values. We want to return the minimum capability of the robber. Else, those conditions don't work, or aren't met. So we just set L to be equal to m plus 1, I think. Yeah. And then we return L. I'm not sure if we need this plus 1 here. I don't think we need it. Maybe we do. Seems this is gonna time out. I'm not sure why we would need it though. Okay, so if we have this +1, then it probably doesn't time out. Yeah. This is the correct solution that I had before. So why do we need this +1? Well, I'll just figure it out later and then put it in like the description of the video or the comments or whatever. I don't know why you would listen to this video though. It's kind of weird.